students, welcome to the another session, and in this session we will be discussing the questions from the concept of rate measure and questions from the rate measure and mean value theorems. So in this rate measure and Lagrange's mean value theorem, Rolle's theorem, etc., these are the concepts we are supposed to do. So the first thing is rate measure formulas. What are we going to deal with in this rate measure? So for example, y is equal to f of x is any function. So dy by dt is equal to f dash of x into dx by dt. So rate measure typically will do differentiation with respect to time. Then we'll go with Rolle's theorem. We'll go ahead with Lagrange's mean value theorem. And the last but not the least, Cauchy's mean value. So main thing is among these three, Lagrange's mean value theorem is known as the mean value theorem. So to talk about the rate measures, etc., we require circle, what is the area, and for circle no volume, only area. Sphere, area. Surface area, volume. Area of sphere, area means that is a surface area, that is 4 pi r square. Volume is 4 by 3 pi r cube. Cone, cone is a right circular cone generally. The right circular cone means this angle will be equal to this angle. So for this one, here this is the height, this is the radius, this is the slant height. Total surface area will be pi r square plus pi rl. Okay, and 1 by 3 pi r square h is the volume of the cone. This is the total surface area, and this is the lateral surface area. Cube, each side is of x units. It's a three-dimensional one. So in this case, area will be equal to total area. Okay, so here this is one face, this is 6 faces are there. So total surface area is 6x square and volume will be equal to x cube. Cylinder is of like this, where the radius is r and height is h. So this is volume is pi r square h, and total surface area. Total surface area means this area, and this one. So this is the lateral surface area, that is 2 pi r h, and if this is pi r square, this is pi r square plus 2 pi r square. So this is the total surface area, and if you take only this portion, that is the lateral surface area. So you need to have the things, okay. And in maximum minimum also sometimes you'll get, okay, the maximum, what you call cylinder inscribed in a cone, etc. Those questions will be discussed later. So what is y is equal to f of x? The average rate of change in y, where x is equal to x1 to x is equal to x2. So the curve is like this. This is x1 f of x1, x2 f of x2. This slope is, that is f of x2 minus f of x by x2 minus x1 is the average change in y. But if I want to talk about at the instantaneous, at this point, what is the rate of change in the functional value y, you need to go for f dash of x. So this is slope of the curve gives us the average, but if I want the instantaneous change in f of x, you have to go for the differentiation. X is equal to f of t, any function dx by dt represent rate of change of f at the time is t. So rate of change of function x, so it is called the velocity dy by dx, rate of change of y with respect to x. So ds by dt is called the velocity, and d square s by dt square is called acceleration, which is nothing but of dv by dt, dv by dt. At x is equal to 0 means particle moving on a straight line and comes to the rest, and distance from the becomes okay. X is equal to 0 means it is the initial position starting and it is going. So if the displacement is x, so if the particle is moving here and started changing the direction, so this is the maximum x. So the maximum x means dx by dt should be equal to 0. That means velocity is equal to 0. And if velocity is greater than 0, displacement is increasing. Velocity is less than 0, s is decreasing. Velocity is negative means this is when you are going positive direction. When it is coming in the negative direction, the displacement is decreasing. Acceleration 0, velocity maximum. Acceleration positive, velocity increasing, and displacement is minimum. Acceleration negative, velocity decreases, displacement is maximum. You can look at here x square quadrant. Okay, so here when the curve is like this is the minimum value. So first derivative is decreasing. First derivative is decreasing means second derivative will be negative. Acceleration is positive means velocity is increasing. Velocity is increasing means you are going to get the thing is okay. And acceleration is negative. Velocity is decreasing. That means dv by okay dv by dt is negative. Next question is, next part is, what is the Rolle's theorem? See, a Rolle's theorem f of x is defined from a to b to r, interval closed interval a to b to r, satisfying continuous in the closed interval, differentiable in open interval. F of a is equal to f of b. Then there exists some c in for x in the interval a to b such that f dash of c is equal to 0. Okay. So Rolle's theorem, you need three conditions. One is f of x need to be continuous, f of x need to be differentiable, and f of a is equal to f of b. Then this one. This is the Rolle's theorem. And look at here, geometrical way of Rolle's theorem. So here, from here to here, let me change the color. So this is f of a is equal to f of b. F of a is equal to f. Then there exists f dash of c is equal to 0 or now here f of a is equal to f of b. The curve is like this. There is one c parallel to, means tangent at c parallel to x axis. F dash of c. What is that? F dash of c means slope of the tangent at x is equal to c. It's not like this. A is here, b is here. So the function is increasing because it is continuous and differentiable. So you cannot have any gaps. So here what happened? Here f dash of c 0, here f dash of c 0, here f dash of c 0, here f dash of c. So I'm talking about at least one c is possible. That is the Rolle's theorem. So f of a is equal to f of b. Then there exists C belongs to A to B such that f dash of C is equal to 0. That is the Rolle's theorem for you. Next one is the Lagrange's mean value theorem. Its improvisation of the Rolle's theorem is the Lagrange's mean value theorem. In the Lagrange's mean value theorem, f of x is defined in the same interval to set, but only thing is continuous differentiable. Continuous and differentiable. But we haven't taken in the Rolle's theorem, we have f of a is equal to f of b. But here we are not taking that condition. Instead of that one, just we are writing f dash of c is equal to f of b minus f of a by b minus c. So for example, f of b is equal to f of a. This is also follows the Rolle's theorem only. Okay. So f of b minus f of a by b minus c. So what is the geometrical interpretation for this one? Look at you. Here f of a is here, f of b is here. So this is the. Now, what is f of b minus f of a by b minus a? Means the slope of this line. There exists a parallel. Now a is here, b is here. So this curve is going like this. So what happened? This is the slope of this line. This. So what happened? There exists here one parallel tangent, here one parallel tangent. So geometrically what happened? If a function is continuous and differentiable, you take any 2 points on this, you take any 2 points on that, there will be a parallel tangent to it. There will be a parallel tangent. This is a comma f of a, b comma f of b. This is C point. So this line, slope of this line will be f dash of c. F dash of c is equal to f of b minus f of a by b minus a. Now, what about Cauchy's mean value theorem? Cauchy's mean value theorem is a combination of two functions, particularly in the limit L'Hospital rule we apply from here only. F of x and g of x are two functions, continuous in the closed interval a to b, differentiable in the open interval a to b, but g dash of x is not equal to 0 in the interval a to b. Then f of b minus f of a by b minus g of b minus g of a is equal. So actually you can write like this. F of b minus f of a by b minus a is equal to f dash of c as per the Lagrange's theorem, and g of b minus g of a by b minus a is equal to g dash of c. So by using these two, I can write this one. Okay, so this is the Cauchy's mean value theorem. Okay, so let us go for the worksheet problems of rate measure. So, what is the first question here? If the area of circle increasing at the rate of 1 by root pi square units per second, then the rate at which the perimeter of the circle changes. Okay, at which rate the perimeter changes when the perimeter is root pi units. So, area is equal to pi r square, perimeter is equal to 2 pi r. They are not talking about r, they are talking about only in terms of perimeter. So area is equal to pi into, from here r is equal to p square by 4 pi square. So dA by dt is equal to 1 by 4 pi, because this cancel, into 2p into dp by dt. They have given dA by dt as 1 by root pi is equal to 2 ones are 2 twos are 1 by 2 pi into p is given as root pi into dp by dt. So root pi cancel, you'll get root pi, and this root pi cancel with this one. So dp by dt is equals to 2 units. 2 units. So instead of writing dr by dt, I'm replacing this radius of the circle with this one. So you can write actually area 4 pi into area is equal to p square in a circle. Next question is two particles are located. What is the minimum distance between these two points? So let me go for the different direct pq square. T plus 1 minus t whole square. 1 plus this minus this. T cube minus t cube gone. Minus 60 plus 16t plus 10t minus 6 plus 3. So minus 3 whole square. Okay. So what is the minimum distance? This is always greater than or equal to 0. When t is equal to 3 by 10, 10 by 3, yeah, sorry, 3 by 10, this value goes to 0. So the pq square minimum value is equal to 1. So minimum value of PQ is 1 when T is equal to this one. There is no point of minimum, so I'll go for the differentiation. Not required that with the observation also. We can tell that one. A container is a shape of inverted cone. Inverted cone means generally when they are talking about the cone, it will be right circular cone only. And height is 6, h is equal to 6, radius is equal to 4 at the top. Right. It's filled with the water. So filled with the water. Water means volume. So dV by dt is equal to 3 meter cube per minute. Then at what rate height of the water? Okay, when this height is, when h is equal to 3, so what is the dh by? So clearly, look at here. If this is the height, this is the height, this is the radius. So 6 by 4 is equal to h by r. So r is equal to 2h by 3. Because when you write V is equal to 1 by 3 pi r square h. R and h are two independent variables, but they have the link because it is going to form always the similar triangles. So V is equal to 1 by 3 pi r square into, instead of r square, let me write this value. Let me write this value. So what you are going to get is equal to 4 by 9 h square into h cube. So dv by dt is equal to 4 pi by 27 into 3h square into dh by h is given and dv by dt has given us 3. So 3 ones are 3 nines are. Right? So you need to substitute the values to get the final answer. So what is dh by dt? dh by dt is equal to 27 by 4 pi into h square. H square is 3 threes and 9 is there. So 9 ones and 9 threes are. So this is going to change it 3 by 4 pi units. 3 by 4 pi may meters per minute. A balloon which always remains a spherical shape being inflated by pumping 10 cubic centimeters of gas per second. At what rate radius of the balloon increasing? So volume of the balloon is equal to 4 by 3 pi r cube. So dV by dt, that is given as 10, is equal to 4 by 3 pi 3 r square dr by dt. 3 cancel. So dr by dt is equal to 10 by 4 pi into radius is 10. So 10 square will be there. Okay. So here it is. Radius is 15 is given. So 15. So it will be equal to 225. So it is equal to 10 by 900 pi. So answer is 1 by 90 pi centimeter per second. So required thing is volume of the sphere is needed for this question. The rate at which volume of the sphere with respect to its surface area when the radius is 4 centimeters. So V is equal to, okay, 4 by 3 pi r cube. S is equal to 4 pi r square. So I require dV by ds. So this is nothing but a dV by, this is 4 pi r square dr by ds by, this one is, okay, you are going to get 8 pi r dr by ds. So there's this cancel, pi cancel. This is equal to r by 2. R by, so what is this one? R is 4 by 2. 2. 2 centimeter cube for centimeter square is the answer. Units also very much. A particle moving along the curve x square by 16 plus y square by 2. So what is this one actually? It is following the elliptical path. So rate of change is abscissa, rate of change in abscissa dx by dt is equal to 4 times of dy by dt. So what is the mean? It's simply dy by dx is equal to 1 by 4. Differentiate here, 2x by 16 plus 2y by 4 into dy by dx is equal to 0. 2 cancel. So x plus y is equal to 0. So if x positive, y negative, y positive, x negative, so it should be in the second or fourth quadrant. The answer has to be second or fourth quadrant. Next question. In each of the choices given below, a function and an interval are given. The correct choice having a function that associated interval for which Lagrange's mean value theorem is not valid. Lagrange's mean value theorem. F of x must be continuous in the interval a to b. F of x must be differentiable in the open interval a to b. Mod x continuous and differentiable. Log x 1 to e, there is no problem. This is a polynomial function, always continuous and differentiable. Only this one. Why? At x is equal to 4 by 3, at x is equal to 4 by 3, this function is discontinuous. This function is discontinuous. So Lagrange's mean value theorem is not applicable. The next question is the next question. If A, B, C are real numbers such that 2A plus 3B plus 6C is equal to 0, g of x has at least one root in the interval 1 to 2. If the function f is defined from 1 to 2 to R, the Rolle's mean value theorem, holds such that f of x is the primitive of g of x. So derivative of f of x is g of x. Then f of x will be equals to. So simply integrate g of x, plus 1 to 2. Look at here, 2a plus 3b plus 6c is equal to 0. I can write it as a by 3 plus b by 2 plus c is equal to 0. Okay, so the g of x will be equal to this integration of this one. So you will be getting ax cubed by 3 plus bx square by 2 plus cx from the limits 0 to 1 is equal to 0. So what you are going to get this value? 2a plus 3b plus 6c is equal to 0. Okay, so the answer is equals to x cube minus 3ax square plus 2x is equal to 0. Okay, so this is the answer you will be getting here. So f dash of c is equal to actually ac square plus bc. Okay, all f dash of x only you write here ax plus bx plus c. So f of x is equal to this value and it is integral 1 to 2 value will be equal to 0. Okay, so f of 1 is equal to f of 2 and there you will get that answer. Next question is the constant c of Lagrange's mean value theorem for this function defined in the interval 1 to 2. Look at here, this function is discontinuous but x is equal to 1 by 4. I am not taking x is equal to 1 by 4. 1 to 4 nothing is there, right? So what is the Lagrange's theorem? F dash of c is equal to f of 2 minus f of 1 by 2 minus 1. F dash of c, derivative of what is f dash of x? F dash of x will be equal to 4x minus 1 whole square and derivative of 2x plus 3, 2. 2 into 4x minus 1 minus, you can take 2x plus 3. Derivative of 4x is 4. So 8x cancel, minus 2 minus 12 minus 14 by 4x minus 1 whole square. So minus 14 by 4c minus 1 whole square is equal to f of 2. F of 2 is 4 plus 3, 7. 7 by 7 minus 1, 2 plus 3, 5 by 3, 5, 1, which is equal to minus 2 by 3. Minus minus cancel, 2 ones are 2, 7. So 4c minus 1 whole square is equal to 20. So 4c is equal to 1 plus root 21. Why I am not taking minus? Because I need the interval 1 to 2. So you will be getting the answer as B as the answer for this question. Next question is suppose f of x is 1, the value of c in the interval minus 1 to 4 satisfying f dash of c is equal to 10. F dash of c, so just you differentiate this one. So when you differentiate, what is f of x here? F of x is equal to x cubed plus x square minus 6x. F dash of c, 3c square plus 2c minus 6 is equal to 10. So 3c square plus 2c minus 16 is equal to 0. Okay. So which among minus 1 to 4, which are the values are going to satisfy? If I take 2, 12 plus 4, yes, satisfying. So you'll take this one. So you need not solve, you can go for the verification directly, you'll get the answer. Rolle's theorem is not applicable for which of the following? Clearly, mod x in the interval minus 2 to plus 2, because at x is equal 0 function is not differentiable. Here it is differentiable. Here it is differentiable. Polynomial functions are always continuous and differentiable. So only the function which is not differentiable is mod x. So the answer for this question is equal to B option is the right one. Moving to the next question, the value of C in the interval 0 to 2 satisfying the mean value theorem for in this particular interval. So f dash of C is equal to, what is f dash of C? That is C minus 1 whole square, okay, plus 2C into C minus 1. Derivative I am doing is equal to f of 2. F of 2 into 2 minus 1 whole square. 2 minus 0 by 2. So this value C square plus 2C square, 3C square, minus 2C minus 2C minus 4C plus 1 is equal to 1. So 1 1 cancel. C is equal to 4 by 3 or C is equal to 0. Okay. So what is the answer? You are going to open interval 0 to 2. So I need answer as 4 by 3. Hope you are understanding. Very simple. Only one basic property we are in. Number of real roots of this function e power x minus 1 plus x minus 2 is equal to 0. Okay. So clearly if I take f of x is equal to e power x minus 1 plus x minus 2. Here I can do in different ways. F dash of x is equal to e power x minus 1 plus 1, which is greater than 0 always. So the function is increasing. As extending to minus infinity, e power minus infinity will be goes to 0 and this is minus infinity. So the function strictly increasing plus minus infinity to plus infinity. So it has to cut the, so one real root is possible. This is one way. For example, x minus 1 for some time capital X if I write, this is e power x is equal to minus x, number of roots for this one. Simple, you can go for e power x graph, y is equal to minus x graph is this one. So how many times intersecting? Only one time. Only one time. So how many roots are possible for this one? One. So this is the graphical way. This is the increasing, decreasing. So next question is diameter and altitude of a right circular cone. Diameter and altitude of right circular cone at a certain instant were found to be 10 centimeter, 20 centimeter respectively. If its diameter is increasing at the rate of 2 centimeter per second, at what rate must its altitude, in order to keep the volume is constant? V is equal to 1 by 3 pi r square h. But here diameter they said. So V is equal to 1 by 3 pi into diameter is d square by 4 h. So what I can do, okay, this constants 12v by pi is equal to d square h. This is remains always constant. When you differentiate, this value will be equal to 0. So 2d into d by dt of d into v plus d square into dv by dt, right? So now what happened? At some moment it is given. So here you look at here, 2 into d, what is the diameter? 10 into v is 20 into what is diameter is increasing at the rate of 2 centimeter per second, plus d square is 100 into dv by dt is equal to 0. So 0, 0 cancel with this one. So dv by dt, okay, sorry, dh, sorry, this is h beta. Please make a change. This is h. dh by dt is equal to minus 8 centimeter per second. 8 centimeter per. Please make sure this is h. Okay. So 12v by pi is equal to diameter square into h. So you are differentiating. So the answer is minus 8 centimeter per second. If the diameter increasing at the rate of 2 centimeter per second, and to maintain the constant volume, the height need to reduce by 8 centimeter per second. What is minus means? It is a reducing. Volume of this sphere is increasing h. So what is the volume of this sphere? 4 by 3 pi r cube. The rate of increase in its surface area. So what is the surface area? Pi r square. Sorry, 4 pi r square. So dv by dt is equal to 1200 is equal to 4 by 3 into pi into 3r square into dr by dt. Now from here ds by dt I need is equal to 8 pi r into dr by dt. So from here 3 cancel, 4 ones are 4 300, r is given 10, r square will be cancelled with this. So dr by dt is equal to 3 by pi. Substitute here 80 pi into dr by dt is 3 by pi. So the answer is equal to 240 square centimeter per second. The next question is the rate at which the area of circle with respect to its radius. Okay, so area of circle is equal to pi r square. dA by dt is equal to 2 pi r dr by dt. So r is equal to 2. So this answer will be equal to 4 pi. So the rate of change of area with respect to its radius, that means you require dA by dr is equal to 4 pi is the answer for this particular question. Next question is, a particle starts from the rest and angular displacement theta is given by this. If the angular velocity at the end of t is equal to 4 is k, the value of k. So angular velocity is dt by d theta by dt, which is equal to 2t by 10, 20. So that is t by 10 plus 1 by 5. So d theta by dt, where t is equal to 4 is given. This is 4 by 10 plus 1 by 5. So what is this value we are going to get? So 2 by 5. So this answer will be, this is equal to 3 by 5 is equal to k. 5k is equal to 3. 5k is 3. d theta by dt is the angular velocity. Means if, for example, this is the center, a particle is moved there, it is moving in the circular way, then this angle is theta. So change in angle d theta by dt is called the angular velocity. The distance s in the meters traveled by particle in t seconds given by s is equal to this one. The acceleration when the particle comes to rest. Acceleration when particle comes to rest. So what is ds by dt? That is the velocity is equal to 2t square minus 18. D square s by dt square is the acceleration is 40. I need 40 when this value is equal to 0. That means t is equal to 3. If t is equal to 3, d square s by dt square will be equals to 12 meters square per second. A ball is dropped from a platform of from here. This is 19.6. The position of the function, how this is going to come. So the formula, yes, here x is given. X is equal to, or s is equal to ut plus of at square. Okay, but when t is equal to 0, this value is 19.6. So plus 19.6. Okay. So what is initial velocity? 0. This one is gone. So x is equal. Acceleration due to gravity increases or decreases. It will be, okay. So when it is coming here. So they are asking its position function. Very important thing, whether they are looking from this position from here or you are looking from position from here. If you are looking from here, the position will be decreasing. Okay, so A is equal to 9.8 meters square per second. Okay, so half 80 square, it is equal to minus 4.9 t square plus 19.6 because as it is coming, this one is. So next question is, and here once. Here why we have taken t is equal to 0? Because it will reaches the earth in 2 seconds of time. Okay. The number of admissible values of C obtained when the Lagrange's mean value theorem applied for f of x in the interval 2 to 5. So f dash of C is equal to 5 minus 2 by 5 minus 2, which is equal to 1. So here f dash of C is equal to 1 always. So every value between x is equal to 2 to 5, every value satisfied this one. So what will happen? Infinite many points are there to satisfy this particular Lagrange's thing. Because y is equal to x, this is the curve. So when you join, every point is the tangent itself. F of x is x minus 1 into x minus 2 defined in the interval closed interval 0 to 1 by 2 Lagrange's mean value theorem. So f dash of c, what is f dash of c? So this will be c minus 1 plus c minus 2 because when you differentiate 1 c minus 2 and this is equal to f of 1 by 2. F of 1 by 2 is this value will be equal to minus 1 by 2 into minus 3 by 2. You will be getting 3 by 4 minus f of 0 2 by 1 by 2. So 2c is equal to 3. This value is minus 5 by 2, which is equal to 1 by 2. Okay, look at here, 1 by 2. So C is equal to 1 by 4. I think these answers are wrongly typed because everywhere 1 by 2, 1 by 5, 1 by 5 only there. So f of x is x square minus 3x plus 2. So when you do f dash of x, okay, f dash of x is equal to 2c minus 3 is equal to f of 1 by 2 is 1 minus 1 by 2 is 1 by 2 with minus sign, and 1 by 2 minus 2 is equal to minus 3 by 2, that is 3 by 4, minus f of 0 is 2 by 1 by 2. Okay, so this answer is 1 by C is equal to 1 by 4. C is equal to 1. Next question is f is defined in the interval 1, 2, 3 by f of x is equal to this one, such that f of 1 minus f of 3 0, f dash of 0, then what is this? So here they are going for the Rolle's theorem. Rolle's theorem. So f of 1 is equal to f of 3. So 1 plus b plus a is equal to, you substitute 3, 27 plus 9b plus 3a. So 8b plus 2a is equal to minus 26, or 4b plus a is equal to minus 13. Okay, so which among these may be satisfying? So look at here, this one is satisfying. Any other thing is satisfying? No, only this one is satisfying. So the function has to be continuous and differentiable, and f dash of c should be equal to 0. So f dash of c means here what happened? 3x square plus 2bx plus a should have a root between 1 and 3. Should have a root between 1 and 3. Delta should be positive. B square minus 4ac should be greater than 0. B square should be greater than 3a also needed. Moving to the next question. The value of c in the mean value theorem for the function x square. So derivative is 2x square. That is 2c is equal to 16 minus 4 by 2, which is equal to 6. So c is equal to 3. C is equal to 3. Next question is, the value of c for Rolle's theorem. For Rolle's theorem, in the interval minus 1 to 1 does not exist either, so you need to check whether it is possible or not. Yes, x square plus 2 continuous, so log of x square plus 2 is also continuous. So here f dash of c must be equal to 0 because f of minus 1 is equal to f of plus 1, which is equal to derivative of this one is 1 by x square plus 2. Derivative of this one is 2x. So that means at x is equal to 0 is the answer. So with this one, I'm concluding this session. See you with some other chapter. Thank you very much.